Hello friends. So in this class we are going to see the derivative of implicit and explicit functions. Okay. So before going with the derivative part, so let us know what is meant by explicit function and what is meant by implicit function. Okay. So first definition we'll see of explicit function. Explicit function means what? The dependent variable can be separated. Now you should know what is my dependent variable now. Okay. So here you know this now, dy by dx. So in this y is a function, x is a variable. Okay. So here in this dy by dx, here y is called as dependent variable, whereas x is called as independent variable, because always this y depends on x. So therefore y is dependent, x is independent. Okay. So here I say explicit function means what? The dependent variable can be separated. Okay, dependent variable can be separated. Then it is called explicit function. For example, okay, I will take x plus 2y is equals to 0. So in this equation or in this function, you can separate x at one side, y at one side. See here, x is equals to 2y, or I can say 2y is equals to minus x, or y is equals to minus x by 2. So if you observe, this y is the dependent variable, this is at one side, x is at one side, means we can separate the dependent variable. Then such functions are called as what? Explicit function. Now second one is implicit function. Implicit function means what? Exactly opposite of explicit. Dependent variable cannot be separated. Dependent variable cannot be separated. Okay. So for that example is sine of x plus e to the power y is equals to 3y is equals to 3y. So here maybe you may see that on the RHS we are having y variable, but one more y variable is here in the composition function. But here it is not possible to separate this y variable. Not possible to separate the y variable on the other side. So therefore this function is called as what? Implicit function. It is called as what? Implicit function. Okay. So I hope that you got the difference between implicit and explicit function. Now next we will see the examples. Yes, now we'll see the examples on implicit and explicit functions. So I'm having the first example, 2x plus 3y is equals to sine x is equals to sine x. Okay. So here you have to find out dy by dx. So in this all the examples you have to find dy by dx. Okay. So finding dy by dx, it means what? You have to differentiate the function with respect to x. Okay. Now here I am going to solve some of the examples from the exercise where you need to find out dy by dx. Now dy by dx, it means that you have to differentiate the function with respect to x. See here, suppose if I say find dy by dx, so here independent variable is x. So with that independent variable, always you have to differentiate the function. Suppose if I say dy by d theta, then you have to differentiate that given function with respect to theta. Okay. So here differentiate with respect to x. Differentiate with respect to x. So here 2 is constant, I will keep as it is. Derivative of x is 1 plus 3 as it is into derivative of y, that is dy by dx. Okay. Derivative of y with respect to x is dy by dx, which is equals to derivative of sin x is cos x. Derivative of sin x is cos x. Okay. But our intention is to calculate dy by dx. So simplify this for dy by dx. So 3 into dy by dx as it is, which is equals to, this 2 ones are 2, plus 2 it is, transfer to that side, it becomes minus 2. Okay. Now here 3 is multiplying, transfer to other side, it will divide. So dy by dx is equals to cos x minus 2 divided by 3. So this is your answer. Okay. So let us take next question, that is ax plus by square, which is equals to cos y, okay. Again same, differentiate with respect to x. So here a is a constant as it is, into derivative of x is 1 plus b as it is, into y square derivative of y square is 2y, into y is again a function, its derivative is dy by dx, which is equals to, now derivative of cos y. Okay, so cos y derivative is minus sin y, but y is again a function, so its derivative is dy by dx. Now if you observe, here 2 dy by dx terms are there, but we should get only 1. Okay, so therefore collect all the dy by dx terms at one side, and the term which is free from dy by dx transfer to other side. Now here a into 1 is a, in this dy by dx is not there, so this term you transfer to other side, it becomes minus a, whereas this minus sign of dy by dx you transfer here, it becomes plus. So this is 2by dy by dx, minus will become plus sin y dy by dx, which is equals to plus a transfer here, minus a. Now in this dy by dx is common, so which is equals to, what is left, sorry, not equals to, so if I take dy by dx is common, what is left in the bracket, this is 2by plus sin y, which is equals to minus a, and this term is multiplying, transfer to other side, it will divide. So dy by dx is equals to, okay, minus a divided by 2by plus sin y. So this is your answer. Okay. Let us take next example. Okay. I will write the example. xy plus y square is equals to tan x plus y. Okay, so we have to differentiate this function with respect to dy by dx. Okay, so here, so when to differentiate this with respect to x, okay, here x into y means what? This is the product of two functions. So therefore here you have to apply the product rule. So what the product rule says, here x is the first function, y is the second function. So first function constant into derivative of second, that is dy by dx, plus the second function constant into derivative of first, so derivative of x is 1, plus y square, derivative of y square is 2y, into y derivative is dy by dx, which is equals to tan x derivative is sec square x, plus y derivative is dy by dx. Okay. Now if you observe in this, there are 3 dy by dx terms. So collect all the dy by dx terms at one side. Okay, already two are present in the LHS. So one more is there in the RHS. That also transfer to left hand side. So here x into dy by dx as it is plus 2y dy by dx as it is. This plus dy by dx transfer here, so it is minus dy by dx, which is equals to, on the RHS what is left now? Sec square x, and in the LHS, see this term, in this dy by dx is not there, so this term transfer to other side. This is plus y, transfer to this side minus y. Now from all the left hand side, all the three terms, dy by dx is common. What is left? X plus 2y and here minus 1, which is equals to sec square x minus y. Okay, now here term is multiplying, transfer to this side, it will divide. So dy by dx is equals to, okay, sec square x minus y divided by x plus 2y minus 1. This is the answer. Okay, I will solve some more examples based on this. Okay, it is next. X cube plus x square y plus xy square plus y cube is equals to 81. Is equals to 81. So you have to differentiate this now. So first x cube derivative. X cube derivative is what? 3x square plus, here again it is product of two functions. So therefore we have to apply the product rule. We have to apply the product rule, that is x square first function as it is into derivative of second, that is dy by dx, plus second function as it is into derivative of first. So x square derivative is 2x plus, now this third term xy square, this is again the product of two functions. So again apply the product rule. X as it is into derivative of y square is 2y, but y is again a function, into dy by dx plus y square as it is into derivative of first. So derivative of x is 1 plus y cube derivative is 3y square. Again y is a function, so it is dy by dx, which is equals to, now RHS is 81. 81 is a constant whose derivative is 0. Now if you observe here, and here, there are three dy by dx terms. So therefore if I take dy by dx is common from the three terms, then what is left here? Here it is x square, in this term 2xy, plus here 3y square, okay, which is equals to, now I underlined the terms which is having dy by dx. The terms which are free from dy by dx transfer to other side, that is this plus 3x square will become minus 3x square, plus 2xy will become minus 2xy, and plus y square will become minus y square. Now here this term is multiplying, transfer to other side, it will divide. So dy by dx is equals to, okay, minus 3x square minus 2xy minus y square divided by x square plus 2xy plus 3y square. So this is your answer. Okay. So I hope that you have understood this example. Okay. So these examples are important as per the examination point of view for 2 or 3 marks. Okay. I will solve one more question, that is sine square y plus cos of xy which is equals to k, which is equals to k. Okay, so let us simplify this question. Okay, I am going to solve this last question from this implicit and explicit function. Okay, so let us differentiate now. What is the derivative of sine square y? That is 2 sine y into, okay, into sine is again a function, so it is cos y, but y is again a function, into dy by dx, because this sine square y, it was the composition of three functions, square, sine and y. So first square derivative is 2 sine y derivative is cos y derivative is dy by dx, plus here again cos of xy is a composition function. So first you take the derivative of cos, that is what, minus sine. Okay, so this plus will become minus sine of xy into, see here angle is not xy, but it is a product of two functions, so therefore you have to apply the product rule. So first function as it is, into derivative of y is dy by dx, plus y as it is, into derivative of x is 1, which is equals to, right hand side is k, which is constant, whose derivative is 0. Okay, so this is 2 into sin y into cos y is sin 2y. It is a formula of first year trigonometric. Okay, minus now this sin of xy multiply inside the bracket, so minus into plus is minus sin of xy into x dy by dx, minus into plus minus sin of xy into y is equals to 0. You have to find a dy by dx. So in this first two terms, dy by dx is common. So what is left? Sin 2y minus, I'll write it x first, into sin of xy, which is equals to, here in this there is no dy by dx term, transfer to that side it becomes plus, so it is y into sin of xy. Now here it is multiplying, transfer to that side it will divide, so therefore dy by dx is equals to y sin of xy divided by sin 2y minus x into sin of xy. Okay, this is the answer. So I hope that you understood these examples. If any examples are left or it is there in the notes, please you practice the remaining examples. Okay, thank you.